So guys, okay, it's recording now, and Ryan here is going to take us into Docker world. Ryan, you can take it up, buddy.
All right, thanks very much. In the chat, I have the link there. You could probably see it on the Chrome too. Just going to start with an introduction. For those of you who don't know me, my name is Ryan Walder. I work inside the Office of the CTO at ENC and in the Research and Development Department. And we work a lot with open source tools. That's been a major change at ENC. And some of the things we've been looking into is Docker and Open Daylight. We've done some investigation ourselves, and I ran into Brent. I knew him a while ago, a couple of years ago, working on the Floodlight project. And he introduced me to Madhu and asked me to do a little talk on Docker for you guys. So that's enough about me.
Thanks so much, Ryan.
Problem. So just off the bat, Docker, what it really is it's a container engine that's aimed at commoditizing Linux containers. So if you're familiar with LXC or namespaces, C groups, clone, any of those kind of things inside Linux, you're kind of well on your way. And a lot of people ask the question, okay, well, what really is Docker, and what can it do for me? The best thing that I can come up with are these kind of simple use cases of it's really lightweight, right, because it uses all basic namespaces. It's really good for automation because of the engine that's kind of wrapped around containers and LXC in general. And it's highly used for content testing and deployment purposes. If you had, I say escaping dependency hell, but if you're going through multiple test frequencies, you can kind of, you'll see later on, but the way that Docker works, you can kind of only do it once and run it many times. It's kind of really beautiful. The way that I've been introduced to it and have been working with it is actually in the platform as a service or kind of X as a service. And this is within OpenStack, right? So if you can get these containers to play with the overlay inside the OpenStack, inside OpenStack, you can kind of see and start to think about, how you can scale these once they are multi-tenant in many ways. So for all intents and purposes, though, the introduction to it is it's really LXC on steroids.
Nice.
So just as an introduction, there's two ways you can run containers. One is through the command line. That's the top part. And there's another. Oops. Okay, we're good with the echo there. And the other one is through something called Dockerfile. And the Dockerfile is the construct of basically commands that you can run a Docker build on, and that will create a brand new image. And this is the bottom section, just giving you an example of, you can actually say, what packages you want and what services you want running. And once you run a Docker build, you actually come out with a specific image that you can then publish to the community, which is really, really kind of a powerful tool once you start using it. So one of the biggest questions that normally people ask is, how's it different than a VM? Like I said before, it's based on namespaces. So you're kind of just using what's already in the kernel, right? You're sharing the libraries, binaries. There's not a normal boot process. You're isolating all the host resources with C groups, which is also pretty powerful. I mean, again, if you're familiar with LXC, this will all sound pretty familiar. But in all intents and purposes, it's not a VM. It's a very, very lightweight construct of resources.
Hey, Ryan, what's the average size that you see?
Sorry, say that again?
What's like the average size of just, I mean, obviously it's application dependent, but is there kind of a generic number that it tends to land around?
So, I mean, most of the images I deal with are all, around like hundreds of megabytes. So you're looking at a very small, you know, kind of image that you deal with. The issue is the way Docker works down the road is once you say you have one image that you really like and you use it for another purpose and you use it for another purpose and you use it for another purpose, it actually does a copy on write mechanism we'll get into, and you keep building on it. So if you do that a lot, you can get up towards like a gig, and that's where you want to get away. But because the whole point is for these things to be very small in nature and distributed.
So Ryan, one very lame question, right? In a VM environment, you can run Fedora on a Ubuntu, on a Windows on Ubuntu, right? But in a Docker LXCs, you're talking about the same distribution should be both the LXCs and the Docker on the base platform, right? We cannot have two different operating systems running on the same machine. Is that right?
Well, yeah. So normally you're not. I haven't dealt with anybody trying to do Windows on this thing, but you can, you know, basically say what kind of Linux distro you want. Usually Ubuntu or of the sort, and as long as it translates down below, right, you can run it. And normally, if you're running these things, you don't really care about the OS. You really just care about what's you know, what you really care about what your host OS is, because essentially, if you're running that, you're then going to use that for the rest of them. So to answer your question, is no, yeah.
So it was my understanding that you could actually do that, Madhu. So I was talking with Florian about this, and we were saying that if I was to spin up my Docker container on Ubuntu, would I be able to run something that had prerequisites on using Fedora? And apparently Docker has the intelligence to be able to do that.
Okay. Yeah. No.
Yeah, that's right.
Yeah. Right. Yeah. I mean, there's a ton of different images out there that you can look for, and these are all like pre-built, or you can build your own. Like at its basis, all you're really sharing is the kernel. So it's really quite flexible in that regard.
Okay, so it shares only the Linux kernel. That's the only thing you share. So that's what you said, right?
Mm-hmm. Right.
Okay. Thank you.
By the way, I joined a little late, but just in case folks didn't know, we do have Docker files for Open Daylight. Yes,
I'm aware of that. Yep. This is more of, we're looking at integrating Docker containers with the overlay. So using OVSDB to kind of do the VIF plugging portion of this, and so they can interact with, you know, OpenStack model type thing.
Right. I mean, that's the hope. Yeah.
It's. I mean, I realize that. Oh, sorry. Go ahead.
Sorry, I was just wondering. I was looking at the pretty rudimentary support for Docker and OpenStack, and I guess I'm not sure. Like in Open Daylight's case, it doesn't seem like there would be any extra knowledge required. All the VIF plugging and everything, that would be done on the OpenStack side. Is there anything specific that Open Daylight has to know to be able to interact with these beyond, hey, I have a VIF plugged into an OVS switch?
Right. So this is kind of where the conversation is leading, right? So it definitely lacks in the driver support on the OpenStack side, and personally, I don't know much about the OVSDB project as far as the VIF plugging goes. I've seen some good presentations from Madhu and Brent, but I think that's where the conversation is going. You know, is there anything else needed from the actual VIF plugging portion of OVS? I tend to think not that much, but I think it's an interesting intersection point.
Actually, sorry, it's Keith here, and I have a question for you, Ryan. And I've already had a discussion with Florian, and maybe Florian's reached out to Dave as well. And since we're starting to talk about OVS and OVSDB and Docker, can you explain to me, and I'm looking at your slide right now, is it feasible to run an OVS instance within a Docker container and have it independently talk to different Docker instances, right? So think like a triangle, right? Because
so the problem is you can't
tied to the
containerize
operating
OVSDB.
Yeah, I was going to say it's normally run outside and then connected to the containers. I don't.
Okay, sorry, go ahead.
You can't do that differently because it's a kernel level construct. Like the kernel is shared between all services, and OVSDB just has the sense that I am just a monolithic entity in the kernel. There's no real way to containerize that as a result. Like you can probably partition it in other ways just by using different data paths, but there has to be care taken. It's not as easy as just sticking in a container and magically works.
Okay, good. Now, I just wanted to make sure that was validated because that was my understanding as well. But yeah, cool. Cool.
All right, cool.
Thank you.
Just to be clear, the OVSDB is not in the kernel. There are
I mean like what
tables
it's
that are in the
interacting
kernel.
with. Right. Yeah.
And there are a number of the core kernel objects that have been isolated by namespaces and therefore can be duplicated per container. For example, the routing table. Or tables, IP tables, etc.
So are you thinking it's feasible then to actually containerize OVSDB, or?
Well, OVSDB is purely a user space construct managing OVS's configuration data in user space. So it would be isolated per container just by the nature that you'd have to have different OVS user space instances per container.
Right. Mm-hmm.
vSwitchD runs in, there's a portion of vSwitchD that runs in the kernel. You can run a fully user space implementation of it if you look at the sandbox. It's in the OVS tutorial. So you could, in theory, run. But like Maroon said, Bridges doing a data path for also probably is going to be easier, and then you don't take performance hits.
Correct.
Yep. All right, thanks.
I'm really curious. Like, you see it as being feasible to be able to fully containerize OVS so that it would be possible? Like, because, I mean, you can kind of do that with, you can have completely isolated IP table or everything in a namespace. What's the limiting factor to doing something similar with OVS and just not have it really, not have that dependency of having things depend too much on the host OS?
If you look at some of the forks, they're pretty much user space forks, like CPQD. Some of those are purely in user space.
So that's a performance issue, isn't it?
Absolutely, yeah. There's definitely a performance trade-off. But like,
so I'm wondering, like,
more and more things are coming out, so it may be reasonable.
Are we moving in a direction where we're going to be able to have fully containerized OVS? Because it seems like the logical missing piece for Docker. It's like we can't reliably run, say, DevStack in a container yet because of the OVS kind of like being halfway between containerized and not. I mean, that's my understanding.
Well, it also becomes, you get kind of stuck in running one version of OVS, and if you want to run different versions of OVS and you also want to have different APIs into OVS, then it's nice to have it containerized. But when I investigated this before, I was told it was impossible because it was so deeply embedded in the kernel. There were kernel portions, right, that made it very hard. But it sounds like
you have to have a compatible kernel
module,
module,
right?
I guess.
Right.
Well,
but Brent, you're saying there's a complete user space. Okay, sorry.
Okay. Sorry, guys. This is Florian. Sorry for jumping in late. Buddy, as you know, we looked at this, right? And
I said that you and I did, right? So it sounds like Brent.
Yeah. No. But so the thing is just like Keith, like when we looked at it, right? Where I left it was that there was a user space kernel. The thing that it was up in the air is how and if the user space stuff would work in a Dockerized container, especially consider that you might have several Docker containers that might have their own instances of OVS, right? And things get hairy pretty quickly, right? but I haven't managed to get the time to investigate if the user space would work, how would that chain and how you'd pass traffic through from the shared kernel to the respective Docker containers and so on and so forth, right? Again, apart from the performance issues that you might encounter, right? That's for later, right? But functionality-wise, it's still not clear to me how would that work. And unfortunately, I haven't just got the time to just look at that. But apparently, there is a user space implementation. I don't know if somebody managed to Dockerize that.
Okay, well, I apologize. I didn't mean to rat hole us, so sorry, Brian. Go ahead.
No
problem. Networking there, and it seemed like an appropriate time to bring it up. But
it's a great conversation.
I have one question actually on that, right? Florian, is there a use case for that? I mean, I understand theoretically what you're discussing is fine, but is there a use case for containerizing the OVS at all?
Oh, yes. Wait, go ahead. Sorry. But I can give you a but yeah, go ahead.
Yeah, so what I've seen in at least what I've been involved with is you want to be able to keep all these things shared, right? And part of the whole thing about namespaces is sharing services like that delivered by the host. But I mean, there's always someone who's going to find a use case to try to do something like that. And I think I heard someone kind of chime in, and there's someone on this call who knows that use case. But I haven't been involved with a use case that has used it that way, but there may be one out there.
Probably just cloud instances more than anything. I know there's been desire to run OVS in the cloud. If the host OS can protect it. If you look in the README on the install, there is directions for user space install and OVS.
Oh, sorry, the use human. I honestly think that a really good use case for this is simply running devstock in a container.
Well, I mean, not only a devstack, for that matter, any sort of OpenStack installation, suddenly you're not bound to VMs and you can run them in containers, right? I mean, you name your own devstack, backstack, whatever, right? I mean, just OpenStack in general. But to Madhu's question, one of the things that, and actually before going on that soapbox, number one is just I wanted to investigate if it is possible at all to start with before starting waxing on and off of what can be done. But one of the things that I was considering is actually chaining traffic between the two different containers, because suddenly you can have, so if within each Docker container you have your own switch, suddenly you can be very creative with how you route traffic between the different containers, on and off between the kernels, and so on and so forth. And again, the imagination is the limit. But in practical terms, right, so apart from just playing around and kicking there to see what can be done, in practical terms, it is running OpenStack within unadulterated OpenStack within Docker containers.
Yeah, sorry, Keith here again. I had a kind of use case we were kicking around with, and I asked about OVSDB inside Docker instances, portability, right? So how can we move around Docker instances and still have them be networked without them being directly tied to any sort of kernel networking? So that was kind of my use case, but then again, I don't know a lot about Docker, and we can talk about it offline if you like, about what my use case is. And maybe it would help if I just shut up and listen to your presentation and found out more about Docker itself.
No, it's fine, actually. I mean, the way that I was explaining it with OVS, only on the host, not inside the container itself. Docker has, a construct of a registry, and technically, if you can move around these containers and orchestrate the network piece from a controller standpoint of view, then it should be able to keep that portability portion of things. But I mean, the OVS inside container is definitely a good conversation, and I more than welcome it. Right,
but before we get there, just again one last thing, and I would be more than happy to participate if there are any efforts there. Is number one, if that user space implementation that's within OVS is at all possible within Docker, right? I mean, that's still a big question mark, because if that's not possible, then this whole discussion is moot, right?
Right. I'll ask tonight.
Yeah.
All right, so we'll go on then. This is more about the actual how the file system is set up. There's multiple different ways that Docker has gone about this. The more recent one has been the device mapper for Red Hat, Fedora, and CentOS-based deployments, because Docker started with union file systems, and the whole point of this is to if you wanted to use someone else's image or container and just slightly change it, you're only writing essentially a diff on top of the actual image. It's one of the things that saves a whole bunch of resources and allows you to scale these containers pretty largely. The two I talk about are Union File System and Device Mapper, mainly for the two distros, Debian-based and Red Hat and Fedora those. Union File System, so I don't know if anybody's familiar with it, but in Docker, an image gets first a root file system, and then any changes you make. So if you install a package, make edits, you can commit these images, and it'll save on top of the parent image that you originally had the container build from. So if you did a base Ubuntu build, and then you installed some packages, ran some program, and then committed it, you could then redeploy that over and over again with exactly your changes and or add to it and commit it again. And this is how Docker essentially, saves a lot of space instead of having to rebuild the whole entire thing each time. And this was, I think, a more recent addition. A Union File System wasn't available on the Red Hat and OS distros as widely, so they've recently put in a device mapper storage driver, which you have to specify when you start Docker. And this uses thin provisioning methods and things like that to keep the flexibility of pushing and pulling and committing Docker containers. So, okay, after all these pieces get put together, you're essentially set with Docker sitting on top of some sort of copy and write file system, C groups, namespaces, and then the kernel. The LXC portion there, as far as I know, in 1.0, the idea is to support it, but actually move towards the native Docker container driver. So it doesn't have any LXC dependencies anymore. I think in maybe the master, this already has been implemented. And this was mainly a dependency issue. I mean, I'm sure a lot of you know about C groups already, so I won't spend a ton of time here. But, Docker allocates the resources to the containers via C groups, so your memory C groups, CPU, all that gets kind of carved up and put into a namespace with the container. The tasks are associated with it, such as like the PID namespace, the network namespace, and etc., UTS namespace, all that jazz. And this is specifically examples from Ubuntu. So one of the things you can do is to kind of play around with this is once you start a container up, this top line here, you can find the namespace PID and and then basically run some IPNetNS to play around with it. This just kind of gives you the idea of how these containers are grouped in the file system, at least in Ubuntu, sysfs, cgroup, devices, Docker. Sometimes in the old Docker versions, it'll say devices LXC, so that'll be a difference. And normally there's something out there called Pipeworks, which actually is one of the guys from .cloud. It's a bash script essentially that you can use OVS networking with containers, but this is all locally, right? Docker actually uses IP tables to allow natting out from the containers and out of the host. One of the things that's pretty common is people go in and take that Pipeworks script and modify it for their OVS instances or VIF plugging, that kind of thing. It's not mainstream in Docker, nor is it really in OpenStack, or I haven't really seen it with many controller examples. The examples I was playing around with early this morning was AUFS, and this was just an example to show you that they're all mounted on this directory, and each one will have its own UUID, and if you have an image with a ton of other images underneath it, those underneath will be read-only, and your commit will be the read-write on top, just as an example. Some of the use cases that we've been kind of looking at, especially within the OpenStack environment, is something like Memcache as a service, where if you had, multiple tenants looking to increase their, web app performance or something like that, they could then, have some sort of portal that says, give me a whole bunch of these distributed Memcache as a service and let me connect them up to my app. And because Docker is so lightweight, fast to deploy, you can have this service in a matter of minutes, right? Instead of waiting for certain VMs to boot all up and then have to install things or have them pre-built or that kind of thing. So that's kind of the model we've been looking at. That's why we haven't really been concerned on where OVS is, but really how OVS connects the containers to the multi-tenant environment. I wanted to mention the registry here as well, because this is one of the ways you can kind of move the app. So if you had one app you wanted to move over to another host, or you had to migrate that application, or someone wanted it, you could commit it to your registry, a local registry or a public registry, and then pull it back down onto another Docker engine, right? Essentially, if they're both running OVS, you can orchestrate that movement as well, and that's not really a big deal. Mainly this is meant for portability, and we use it internally.
It should be noted that that's actually how it integrates with OpenStack, because you store Docker in the Glance registry.
Right. It integrates with Glance, and you can use it that way. Yep. The networking part, I think this was we already had this discussion really. Docker lacks support in OpenStack, and it also doesn't have any native support for Open vSwitch in their Go implementations. So right now it uses IP tables, so you can NAT out. You can use Open vSwitch, but it's kind of an ad hoc way. This is this Pipeworks script here. So one of the ways we did this was basically through a Python wrapper or over top of these Pipeworks thing, and you can manipulate OVS into providing the right information and right metadata to whatever said controller. So I thought
it's really
this
easy.
was.
Sorry. So the fact that Docker is not actually stable in OpenStack is the biggest impediment to getting OVS support. Support is really trivial. Literally all you have to do is do a VIF plug and then tie one of the VEF pairs into the correct namespace. Like, technically not a problem. But
yeah, I'm completely aware. I mean, we've done this at ENC with the Nice Hero stuff. It's been pretty trivial, but I mean the fact that it's not there and that there was some interest from some of the guys in the Open Data community is really why we're talking about it. And if it turns out that it's not really something very useful or that we don't want in the community, then so be it. But I think
I guess I'm just confused because there's already all the infrastructure required to tie Docker to OVS already in Nova. It just hasn't been plugged in because the Docker folks are too busy working on stability things.
Sure. I mean, I spoke with Brent, and this was the the idea of let's get a talk around whether OVSDB supports this. If it does, great. It's probably really trivial. So that may be the case, exactly. I mean, I know all the support on the OpenStack side is pretty trivial. So,
I mean, it just like if you use the VIF plugging mechanism, it just means that there's literally no change required between the Docker container and a VM. OVSDB will register that a port was plugged in. There'll be metadata that'll be there that'll allow it to configure that port. It'll literally be identical. So, I mean, it's awesome because, trust me, I love Docker. I want this to happen, but I've just been waiting on the Docker folks to stabilize support so that I can actually target it for, the sort of limited development that's required.
Sure. No, I'm not arguing that point at all.
So, all you're saying here is the OpenStack integration for the Docker and OVS is not there, but as Mauro pointed out, Docker and OVS can already work, just that not in the environment of OpenStack, right?
Yeah, this is what it looks like right now. So, and he's saying all the infrastructure is there where you just really need that. You just need to tie it together where you actually give Open Daylight the information it needs, because right now Open Daylight can handle that, and so can the container, but the driver portion is non-existent.
Got it. Thanks.
And that was maybe something that I haven't been following as much as the OVSDB project as all of you guys here. So it's all the infrastructure is there. I mean, Brett and I had a discussion and said, like, I don't think there's really much that needs to be done, and maybe nothing. So that just may be the case, and maybe the work's really just on the OpenStack side or whatnot.
I think that would be my assessment. Maybe I'm missing something, but just the fact that there's this sort of interface already there in the form of VIF plugging. I mean, we already have a mechanism to transmit the information necessary to configure things. It really isn't different between Docker and a VM. It'll be interesting because it has the potential to add scalability concerns where they didn't exist before. You're like, oh, I can run, so many VMs, and still have performance. And it's like, oh, I can run a factor of 10 more containers. Oh, shit. I have to actually be able to handle that level of VIF plugging and that rate of VIF plugging. So it'll be interesting. And to my mind, one of the use cases that didn't appear there that I think is really awesome as an OpenStack developer is for testing. Because right now, if I want to, I have to deploy OpenStack, I got to boot a VM, I got to wait for that VM to run through its configuration. Wow, if I could just have instantaneous, like VM-like containers, I could test connectivity a heck of a lot better, a heck of a lot faster. So it's really awesome.
Yeah, I mean, agreed. I think people want it. I think the Docker community, as far as I can tell, has been focused on the file system portion, and just has recently got back into what they want to do with networking. So they may support a lot of OVS internally, and it's just like someone needs to just get up and do it for the OpenStack part. So,
right. Hey, Marin, is there any use? I mean, I know we've talked about the VIF plugin before. I mean, there's definitely some inefficiencies when it comes to that, as far as polling and that sort of thing. I mean, is this an opportunity for us to look at doing it differently and have a more native support with, using OVS?
What do you mean by polling?
So if you look at what actually happens with the VIF plugin, it actually polls libvirt. So every 2 seconds, the entire configuration of OVSDB is dumped and then diffed. So rather than doing more of a...
I guess I'm confused about what layer you're talking about.
Brian, so let me cut to it, right? Madhu, not sure if he's still on the line, but me and him, we just chatted a few ideas back and forth. The thing is that you're on the right track, because in my mind, and I'm more than happy to be proven wrong, a quote-unquote proper Docker container would avoid the libvirt mumbo jumbo. And with that, what would that imply is that we will need to take a careful consideration. How would that plug in directly into Neutron or directly into Open Daylight, right? But that's a very valid point, right?
I guess I'm kind of confused as to what, I mean, when I talk about VIF plug, all I'm really talking about is getting like a VEF pair and, tying one into the VM, or in this case into the Docker namespace, and plugging the other into an ODS bridge. So where exactly is this polling going on?
Well, so I'm not sure on Docker. I do know on, if we're just talking like generic KVM type stuff, with libvirt.
Well, libvirt is not involved in Docker, the Docker driver at all. So
right.
When I say VIF plug, I'm talking about the same mechanism. I have port details. I'm going to basically, like the VIF plugging to me, the operation, and maybe I'm naming it wrong, is where you create a VEF pair, and then you plug one in into OVS, and you pass it the port metadata that you received on port creation, so that whoever's monitoring OVSDB can say, oh, that's this port. I need to wire it, this way. It's just a way of, communicating to the controller.
So that monitoring, the actual monitor method in the RPC is done like with a client today, and it's just give me every bit of your configuration every 2 seconds. At least that's what the libvirt plug implementation looks like.
But I'm saying that we don't even have to consider that in the Docker case, or we're changing topics.
Got it. Okay.
Oh, okay. So that's just we don't have to worry about it in that case at all.
So I guess how do you track state when a new container comes up? How do you know that a new container has come up?
So there's a logging mechanism that is output to JSON in Docker. There's also, once you know specific containers, you can run an inspect. It's basically called Docker inspect, and it gives you all the information on a single container. So those two methods together, you probably need to use.
Well, why would that be useful? I mean, Docker isn't multi-host. I kind of see that.
No, right.
Sorry, go ahead.
I mean, as far as the question, that's where you get information about everything that's going on in the Docker engine. I mean, I don't know, you may not, like you said, that may not be important for what we're talking about, but as far as Brent's question goes, that's kind of where you find that information.
I guess for me, it's like I don't see booting booting Docker instances outside of some orchestration layer is useful, because you have to be able to tie like the network configuration into Docker somehow, and they'd be duplicating. Like, it would almost be better if you had something like Neutron. I'm not saying you have to use Neutron, but something like Neutron that tied, VM or container booting to. Oh wait, but you actually want to do that with Open Daylight, don't you? Sorry, the gears are turning slowly.
No, dude, we need you, Marin. That's why we have you, brother. You ask the questions that we don't think of.
I mean, one of the issues that I've seen with Docker and integrating with OVS is that most of the time Docker isn't aware of that OVS construct, so it doesn't. If you look at specific Docker state, so a container state. It doesn't have the VETH pair information, right? So that's not plugged in through Docker yet. So if you move this, you wouldn't carry over any of that state. So like in that case, there is work to be done on the Docker side, but definitely, not really at all on the Open Daylight side.
I don't think Docker can do it though, frankly, because their speed of development, writing stuff in Go, is going to be like an order of magnitude slower than something like OpenStack writing in Python. So it's like, yeah, you can do it at that level, or you could just focus on, the image management is where Docker really shines, and do orchestration in a language that actually makes sense for orchestration where performance isn't as critical. But that's my biased view.
Well, so I think it probably helped me in kind of listing what value would Daylight or what value would network services bring to Docker. For getting CRUD on ports for now, I think security is going to be a really important one. Is how do we maintain, how do we create tenancies, regardless of what we key off of between application instances or container instances? Is that
I just don't think it's worth.
I
don't know. My honest opinion is that as if I'm never not honest, but I guess I look at integrating directly with Docker as kind of like it's too soon. The question is, where can you integrate today? And you can integrate with something like OpenStack. So I think getting Docker support for OpenStack working and focusing on that integration, and then we have to see how Docker develops, whether they actually are going to grow their own management orchestration facility. And if so, then you already know how to deal with it in OpenStack, and it'll just be a matter of translating that model to whatever they expose. But they don't have a model yet, and there's no point in building one around it, from scratch, if something already exists and you can focus on like more interesting problems. But I'm biased, so that's all.
No, I mean this is the exact conversation we were hoping. And that may be the case. I mean, when Brett and I were talking, we wanted to think like, hey, what's really the value, and why should we integrate Open Daylight and Docker, and is there any push for it, or would people use this? And I think when it boiled down to it, I thought the same thing as you, saying, hey, like most of this that the intersection point is really the OpenStack portion, and once you say, hey, you can have like multi-tenancy and overlay working, and that's basically good to go with Docker, then it's like we look at Docker and say, what have you been doing? Because their development's fairly slow, and they're looking to push 1.0, I think, out fairly soon. So they're pretty under heavy development, so things are changing all the time.
So when we, hey Maroon, do you remember when we talked to the app guys? It seemed like, so advanced networking, where they're actually looking at payload headers, that was picked up through HA proxy, and then but there was this need where they needed tenancy on the back end, basically to be able to wire in tenants to one another and create an overlay basically just for one tenant. I mean, the good thing is, like you say, this all kind of marries up with what we're already doing, the same model we're doing with OpenStack integration. You know what I mean, though? Do we want to look at wiring the back end, or, and then I guess what's the state of OpenStack integration today?
It's coming, but they have stability problems. They don't have good testing. Like there's literally no CI for the Docker driver yet. They were supposed to get it this cycle, but in the absence of that, changes happen both to Docker Registry and to Docker that break the DevStack support, and it's like nobody can work with it. And unless you're a Docker expert and you know all the ins and outs. So I mean, I took a stab at it because I'm like, oh, this should be easy. And then Docker was completely unstable, and I couldn't get it running to test it. I mean, Docker's easy to get running. It's OpenStack with Docker that I don't think I've ever gotten reliably running. Like it ran the first time I tried it, and then a week later it was broken. And it was broken for a couple of weeks, and I haven't tried it. I just kind of gave up after a while. It'll come though. I mean, think it's a matter of time and the right people having resources to focus on it. And once we have CI, then at least it can't break. People will actually notice and fix it before users or developers are affected.
Got it.
Mm-hmm. I mean, Brent, to your point, as far as, as much as I can say about it, we've seen specific use cases for that kind of idea where Docker allows you to kind of have the container both on the overlay and be able to kind of NAT out to a public address space. So you can kind of look at that as a gateway model. So in terms of storage, like you look at cloud gateway models and you kind of say, oh, hey, look, that would be pretty interesting. And that's kind of where we see it intersect that, hey, we need these containers to participate in the overlay space, that logical space, so we can have multiple tenants use these things. So, I mean, there's use cases for that specific thing, but as far as OpenStack goes, it's just non-existent.
Got it. Hey, Florian, do you have anything on top of this? I know you've looked at this quite a bit too. What were your conclusions?
Well, buddy, like I said earlier, right? I mean, for me, the task at hand is clear, right? So we know how to put Docker and OVS together, right? That's done. I'm not sure if I showed you that already, or I think I'll show you the diagram. That's done, right? The thing that is a bit iffy and a bit softer on the edges is the Nova driver for Docker, right? Number one is that today it works only with Ubuntu. Trying that on Fedora doesn't work because of the tricks that they meaning the Docker driver is pulling off to run its own registry, its own images, blah, 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 within OpenStack. So that needs to be cleared up. And then, like Ryan, absolutely correct, and puts exactly spot on the driver.py bit of code there, is that needs to be fixed. And that's pretty much it, the way I see it, right? And we had, I think it was about 2 or 3 weeks ago, we had discussion with a quick exchange with Ashwin on the line, and his opinion was, which is pretty much my understanding, that basically there is a extension to Neutron for the VIF driver. That's pretty much need to be there, right? But that's my assessment of the situation.
Okay, killer. So it sounds like consensus is that this is interesting for all of us, but probably next, this time, maybe this fall, we revisit it. And, maybe Maroon, if you can keep an eye on how it develops on the OpenStack side, and obviously, Ryan at the meetup, if you hear anything that changes things.
Sure.
Revisit.
I mean, Ryan, let's do this. Let's you and me have a brain melt offline, because again we're 1 hour in the call and we haven't get to the OpenDaylight OVSDB stuff yet, or at least not tangentially. So I don't want to suck all the air out of this call. But let you and me connect offline and kick the ball further there and see. We'll get back to the team when we get crystallize on what's needed, what bits and pieces need to be there, and on which side they fall.
Yeah, that sounds fine to me.
Cheers, mate. Thanks.
Awesome, Ryan. Thank you so much, man. That was really cool. It cleared tons of I hear Docker nowadays, and it's it's a shiny object, and now
yeah, I mean, there's definitely a lot of.
It's awesome. Imagine being able to create an isolated environment on your bare metal machine and run it full speed with no I/O penalty. Are you kidding me? I'll take that any day.
Well, and that's the other is it sounds like what we do want to look at, and so I'm sure somebody's going to take it away, and maybe we can talk, just give an update next week on getting OVS running in user space. If you look at the README and just the root of OVS, there's directions for compiling it for user space only, where it's not going to churn out the kernel module. So I don't see any reason that wouldn't. There's been a lot of talk on, if you just look on the listserv, the OVS discussed listserv, it's full of user space OVS. So maybe you got to
figure this out.
I'll have a look because I'm interested.
Yeah, if you guys can figure that out and I don't know, post instructions or whatever, because that's kind of a limiting factor for me. I would totally love to be able to run DevStack in a container and never look at VMs, like, because to be honest, like on the networking side of things, I don't really care about compute. I care about the machinery that like will be able to pull up a new container, but does it really matter to me whether I'm running a VM or a container? No. I just need something that has connectivity and can respond to network service requests, and I can configure that in a container just as easily as a VM.
Huh.
Right. And performance there isn't even is kind of a non-issue. So yeah, it can definitely be done. So maybe we just kind of crank out an image with that with our DevStack stuff. That might be pretty cool.
Yeah, totally. Please keep me posted.
And I think long term, I think there's a lot of interest in like a cloud image. Sorry, go ahead, Madhu.
I'm sorry, guys. I mean, Ryan, thanks a lot for this one, and I have to run for the next meeting. It's excellent. Thanks a lot, buddy.
No problem.
Yeah. Bye.
See you, brother.
Hey, thanks, everybody.
Bye.
Thanks, guys. Is there anything, Ryan? Again, thank you so much, man. I know we're kind of out of time. I didn't really have anything else prepared just because we've been at OVS. I've been heads down this week actually trying to get things done instead of talking about it on slides for the past 2 weeks. So